Section 7.3, proving triangles similar. We're going to use angle-angle similarity postulate and side-angle-side similarity and side-side-side similarity theorems to find indirect measurements. So here's postulate 7.1. Let's do the title. I usually use the part that's in the parentheses there. We know that the tilde responds to or refers to similarity, so AA similarity would be angle-angle similarity postulate. And just do the words only, please. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So it basically gives you what the theorem says in the title, because you have two angles the same, and then the similarity part. So in the picture, angle S is congruent to angle M, and angle R is congruent to angle L. They have them marked. These triangles are similar then, if that happens. So now we have more ways to show that the triangles are similar. Remember, they're not congruent. They are similar. And you can tell that in the picture that the first one is smaller than the second one. So all the angles are going to be congruent, but all the sides will be proportional. So let's see how this one works in the next question. Now I've left something out, so let me add that really quick. This should be triangle. So, are the two triangles similar? How do you know? So we're looking at the triangle on the left, which is RSW. Is that one similar to the triangle on the right? VSB. So basically the only thing we know right now on how to show that they're similar is that by definition, are all the angles the same that correspond to each other, and are the sides proportional? We can't do that on this one because we don't have any sides given, and we don't necessarily know what all the angles are. So they have to give us something else that we can use. And this time we need to show, are there two angles that are the same? Two pairs of angles. So we already have one. It's right here. So I'm going to say angle R is congruent, not similar, they are the same because they're both 45, to angle W, or V. Okay. Do we know another angle that is the same?
Yes.
And what is it?
WSR and VSB.
Yep, so we're looking at these two. And they are what kind of angles again? Vertical. So we're going to say, and we can't say angle S to angle S because we don't know where we're talking about then. So we're going to say WSR is congruent to, now remember I went WSR, I went backwards with those letters. I'm going to do the same thing when I write this one out. So BSV. And these are vertical, if you've forgotten what that is. Okay, you don't necessarily have to say that, but you need to know it. You can't just pick any random angles that are the same, and you would have to, well, it does say how do you know, so I guess we do need to know that. So we're going to say triangle RSW is similar to triangle VSB by angle similarity postulate. That's it. So show the two angles that are the same and say that they're the same using, I would probably just get used to using the AA similarity postulate instead of the postulate number. So this one does work. Let's look at another one. How about this one? So we are looking for is triangle, and I don't know if they give it or if they just do the pictures. Let me see. No, they just did the pictures this time. We're looking for, I'm not going to write that yet. We're looking for two sets of angles because we don't have any sides again. They don't touch or anything. So do we have two angles that are 30?
No.
Okay. How much would this one be on this side? We'd have to subtract from 180 to get that one, right? So 180 minus 70 would be 110. If you subtract 85, you get 25. Okay, we also need to find out this one. So 30 and 70 are 100, so K would be 80. Okay, so do that. If you have two angles already there, find the other ones to see if they even match. So we have two angles that are 70, that's okay, but the other two pairs do not match, so these are not similar, okay? So I'm going to say not, actually I'm just going to go like this. These are not similar because there's only one pair of congruent angles and you need two. Okay, and we could say that as well, I guess. Okay, so super, super easy. Easy to explain. Show those missing angle measures though, so I know that there aren't any that are matching. So here's got it question A. Again, on this one, there are two angles that are given. So first we need to find the ones that are missing and see if they match. So when you're looking at the first one, 180 minus 90 is 90. 90 minus 39 is 51. On the second one, if you take 180 minus 90 minus 51, you do get 39. So are these triangles similar?
Yes.
Do we have to do a similar statement though this time? There aren't any letters, right? So you're just going to say, yes, they're similar. Or just do the symbol because they didn't give you like triangle ABC or anything like that. So we're going to say, yes, they're similar. Two pairs. And there's actually three, but according to the postulate, we only need two. So it does follow that angle-angle similarity. On the next one, do we have two pairs of angles that are the same? I don't know, we got to find them. So on the one on the left, there's two sides the same. This side goes with this angle. This side goes with that angle. So we know this one is 68. We would have to subtract from 180 to get the other one. And so this one is 44. Same thing here. On this one, it goes to this angle. This side goes to this one. So those base angles on the left are the same. They would both be 59. Are there any pairs of congruent angles on this one?
No.
No. So you're going to say not similar. No congruent pairs of angles. Okay, so you don't have to go through and match everything if nothing necessarily works. Okay, so here's theorem 7.1. Use the symbol again. SAS similarity. This one says, and just use the words, if an angle of one triangle is congruent to an angle of a second triangle and the sides that include the two angles are proportional, then the triangles are similar. This one, there's a little bit more to it than just finding two angles that are the same. So this one is much harder. So I'm going to give you a minute to do that one. If you finish that one, go ahead and do the next one as well. Side, side, side similarity, SSS, use the symbols. If the corresponding sides of two triangles are proportional, then the triangles are similar. So we'll look at those kind of together. I'm going to make it just a little bit smaller so you can see both. Okay, so let's look at the first one really quickly. Side angle side. Now we've already done congruent triangles with side angle sides, so you know what that looks like. Notice how the two sides that are given, it's the angle that's between them, or it's the angle that connects those two sides and actually makes an angle. That's the one you need to be aware of. And secondly, you have to look at this proportion that they set up. Notice they have the reds on the left, the blues on the right. So they're taking the side on this one that corresponds to the side on that one. You cannot do AB over AC and stick to the same triangle. You have to pick one from this one, put it over one from the other one, and then you're going to do the same thing with that other set of sides. So that's the key thing that I think students have done wrong in the past. They want to stick to that same triangle and you can't. You're looking for sides that look the same or are on the same side of the triangle that you're looking at. Okay, look at the next one, same thing. On this one, you're looking for all three sides being proportional. The red sides are compared. The blue sides are compared. The purple sides are compared. So you have to pick one from the left triangle, match it up with one from the right. All those ratios should simplify down to be the same number. If they don't, then they're not similar triangles. Same with this one. If you simplify down those two ratios and they're not the same, the triangles aren't similar. The angle more than likely will be something that is the same. Not always, but most of the time they get you on the sides, not the angles. So let's look at this one. So with this one, and you can kind of tell ahead of time which of those theorems that you're going to use, because are there any angles given on this one? No, so we're not going to use angle-angle similarity because we don't have any angles. We don't know that they're even right triangles because the square isn't given. So we're either going to use the two that we just did, side-angle-side similarity, or side-side-side. Since we're not given any angles, we're going to use side-side-side. So we have to set up the ratios to see if they all simplify down to be the same. Notice how in this one, it kind of looks like a right triangle even though it isn't. The longest side is 10, the shortest side is 6, the middle one is 8. Kind of keep in mind those things. So what's the shortest side in this one over here? The VX or the 9, right? So we're going to compare the 6 to 9. And I chose from the left one first, so I'm going to choose from the left one again. I'm going to do the one in the middle, 8. Would match up with 12, and then the angled side, which is 10, needs to match up with 15. Then you can grab your calculator and type in 6 over 9 and hit equals. Do 8 over 12 as a fraction, hit equals, and it'll simplify for you, or you can, of course, simplify them in your head. I'm going to divide by 3 in the first one, so I get 2/3. I'm going to divide by 4 on the second one, and I get 2/3. And 5 on the third one, and I get 2/3. Okay, if those numbers are all the same, they are similar. So we're going to say yes. Similar by side, side, side similarity theorem. And that's it. You do have to show all of this. You can't just say yes, side, side, side similarity. You got to show it. So kind of like on those triangle ones or the picture ones where you had to show if they were a rhombus or not. It's kind of like that. You have to do something to show that. We should do a similarity statement too. If you didn't do that on the last one, this might help. So don't forget the similarity statement. I'm going to do short side, long side, like the side that would make up that right angle if there was one. I'm going to go STU, so the T is kind of like that right angle spot. So I'm going to match it up with XVW. Okay, so I said triangle STU similar to triangle XVW. You cannot just do random letter order. They have to match. So ST should be the same length or not same length, but similar length as the side that is the first two letters, XV. So you do need that as well. If they don't give you letters, then you can just say yes or no. Okay, so here's some overlapping triangles. So I want to kind of separate them for a second. When you guys do these, you don't have to do this separation thing. I just want to show it to you on this one. Okay, so the small one's pretty self-explanatory. I'm going to take this out. Those two side lengths are 8 and 12. How long is KM? 10. You can't just use the 2. You got to use the whole entire thing. So you got to add them together. So if you're choosing not to separate the two triangles, you have to add them. You have to remember to add them together. So then 12 plus 3 would be 15. And this one was 8 plus 2. Okay, now we can compare those two lengths. Do I have an angle that's the same on this one? They overlap, so they have to, right? So angle K does match. Even though they didn't mark it, you can mark it because you know for sure that that is the same. So I'm going to have angle LKP is congruent to angle MKN. I would let you do angle K congruent to K on this one because there's no doubt what angle K is. But just so that you know the letter order. Then I have to show the proportional part. So I'm going to say 8 over 10. 1 from the left triangle, 1 from the right triangle, and then 12 to 15. If those two simplify down to the same number, we're good. So divide by 2 on the one on the left. Divide by, let's see, 3 on the one on the right. So scale factor equals 4 over 5. Yes. And I'm going to do the same order as I did my angles. LKP, similar to MKN. Side, angle, side, similarity theorem. So kind of a lot that you have to show, but it doesn't take that long. Okay, so 2 sets of sides need to be the same proportional length and 1 pair of angles. If they overlap, you can always separate them like I did, but you don't necessarily have to. Okay, let's look at got it question 2. Are the triangles similar? If they are, write a similarity statement. Explain how you know. So obviously they're looking at sides, right? No angles are given. So we're looking at this one. So kind of have an idea in your head which one you're using first, because then you're going to know what you have to write down. If it's sides, you need 3 sets of fractions that all simplify down to the same thing. So if I flip this one down, would they look the same? If you just flip it down, they would look the same. So I'm going to match 6 up with 8, 9 with 12, and then of course 6 with 8 again. Oops. So 6 over 8 simplifies down to 3 over 4. If you divide the next one by 3, you get 3 over 4. And obviously we've already done the other one. So we're going to say yes. Triangle ABC, similar to, how are we going to write the other one? How do you know how to do that? If you flip it down, could you do EFG? Could you do FEG? How do you know what to do there? If there's 2 sides the same, wouldn't there be more options of writing it down? Because if you flip it down, it might be different than if you rotate it up. You know, I mean, you should be able to nail the one down, but sometimes depending on the side lengths, there might be more options of letters that you can write. I'm going to go A, B, C, and I'm just going to pretend I'm flipping it down. So I'm going to go EFG. By side, 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 similarity theorem. And the scale factor would be 3/4. So if they ever ask you what the scale factor is, it's that fraction that you found, you know, the simplified version of it. Okay, take out your homework, please, and I want you to try this one. So are these similar, and how do you know? So looking at these, you could separate them if you wanted. Is there an angle that's the same, first of all? Angle A. So I'm going to say angle A, congruent to angle A. If you want to do 3 letters, you can. If you separated them and did 3 letters, that's totally fine. Angle A congruent to A, you don't wonder what angle A is. It's right there. Then you check the sides. So you take one length from the one on the left. I'm going to use AW first. Don't do 6 over 6. It's going to be 6 over 12. And then you're going to do the one at the top. It's going to be 8 to 16. Each of those reduce down to 1/2. So scale factor equals 1/2. You have your angles that are the same. So triangle AWL, similar to triangle AEC by side angle side similarity theorem. And you pretty much need all of that. So write down the angle pair. Most people that get something wrong on these forget that angle pair needs to be there. It isn't just side, side, it's side, angle, side. So you have to name every single thing that you're using for a reason there. Okay, last one, indirect measurement to find lengths that are difficult to measure directly. So we have a rock climbing place. Darius wants to know how high he will climb. He places a mirror on the ground and walks backward until he can see the top of the cliff to the mirror. Probably you're not going to do this in real life, but it's an example anyways that they're trying to relate to real life. What's the height of the cliff? So they're taking and comparing his height to the height of the cliff and also the height or the distance from that mirror. So they both are right angles, so we already know that there's an angle the same. So angle T is congruent to angle S. Now let's compare his height to the height of the cliff and then the distance from each comparing as well. So I'm going to go 5.5 to the height of the cliff. That's the one we don't know. And we're going to set it equal to the distance from that mirror. I did the triangle on the left first, so that's the one I'm going to use, 6 over 34. So you're setting up these fractions the same as you would if you're using the theorem, except now you've got a missing variable. So you're going to take 34 times 5.5 and divide by 6. So here, all you need to show is that setup, and then once you multiply, you are done. So the application questions on these are actually quite a bit easier than doing the finding out which theorem or postulate you're using. So the answer would be 31.2. Would it matter if you went from the right triangle to the left triangle? No, basically it would be 6 over 34 equals 5.5 over x. It wouldn't matter which side you started with. You could have x over 5.5 equals 34 over 6. There's lots of different ways that you can do it. The only thing I do not want you to do is 5.5 over 6. Don't take these two over each other because those two do not compare. It's this one to that one, this one to that one. So as long as your setup matches that in some way, you're good. If you do 5.5 over 6 and x over 34, you'll get half wrong every time because that's not what the theorem says. So make sure that you're going by the theorem, not by just some random setup that you came up with on your own. So make sure that you have the setup. Here they don't tell you to give a reason, but I still want you to look for that angle. I wouldn't count it wrong if you didn't write it down. Because you are kind of doing the reasoning part in your head on this one, so you wouldn't necessarily need the angle. You would need the setup as well as the answer.